it's Kathy Deeks, and I'm here to give my final interactive case study number 8. I'm using a different computer here, my work computer, because it has PowerPoint on it, which I'm very, very familiar with, and nothing else has worked for me in this entire class for recording, so I'm just going to see if I can make this screen bigger. Let's see. Of course, nothing works here. But anyways, exit drawing. Wow, this is so crazy. So I'm going to put this in the center so that I can see this better. And here, instead of me being there, so you can see this computer screen. Okay, so I have, I chose Prograph, and that is one that we use in my transplant center. And I'm having troubles with the connection, so I just have to bring this up again. This has been one thing after another for me in doing recordings here, and I never usually have this kind of trouble. But I've done professional presentations where we have trouble like this too, so you just sort of get along, get by, crack a joke. I, of course, have everybody take a deep breath, stand up and touch the sky, touch their toes, whatever I might feel comfortable depending on what the audience is. Okay, here we go, slideshow. All right, well, I don't know, it's not gonna go to the next slide, so here we go. So Prograph is a macrolide antibiotic. Its mode of action is similar to the cyclosporine immunosuppressant that is often used, but interestingly, the concentrations are 100 times lower for this drug. It bonds to immunophilin FK506 binding protein. The way it works is that it inhibits calcineurin phosphatase. And so that would be the calcium-dependent events like interleukin-2 gene transcription, nitric oxide, synthase activation, cell granulation, and apoptosis. It potentiates the action of glucocorticoids and progesterones. It can enhance the expression of the transforming growth factor, beta-1 gene, and it does have a lower allograft rejection rate compared to the cyclosporine A. I also have, well, let's see. I guess I'll try to get to the, okay. So the way that the immunosuppressive drug works is that by engaging antigen receptors, this induces calcium influx from the extracellular space. Calcium enters lymphocytes by store-operated calcium channels. By identifying the pore-forming unit and the sensor of stored calcium, there is molecular manipulation of the signal transduction pathway. And then here, I was able to pull up that signal transduction pathway that's involved in the T-cell activation. Sure, hoping that you can see this. I had also brought some flowers out from my mother's funeral. But regardless, so we have this pathway here, and the provision of the antigen-specific and cytokine signal leads to the T-cell activation. A number of the pathways exist that transduce the signals from the surface of the T-cell to the nucleus. And the end result of signal transduction is the transcription of mRNAs that code for a variety of pro-inflammatory proteins. The numbered steps here depict the sites at which the various immunosuppressive agents are acting. So if I can point this out here, number 1 is that we have the this is how the cyclosporine one works. Number 2 is, here's the tacrolimus, or the prograph that I'm talking about. Number 3 is, so these are all working very similar, rapamycin, and number 4 is the corticosteroid. Okay, and let's see. Wow. Oh, I had excellent resources, and I lost track of time reading all kinds of things here. But I also wanted to point out that the downregulation for this pathway, I had to just print off the picture. We've got this calcium, the activation cascade includes calcium binding to calmodulin, which leads to the binding of the calcineurin. And the activated calcineurin can dephosphorylate the cytoplasmic unit of the NFAT, which allows for translocation of the NFAT from the cytoplasm into the nucleus to form a competent transcriptional activator of the IL-2 gene. Okay, and then finally, that's funny, the last of my references are gone. Let me see, there's looks like that's just a new slide. Yeah, so here's my other reference slide, and again, I lose time on looking at all this stuff, and so that's what I've got. Okay, thank you.